All right, good afternoon, everyone. Thanks for coming along. Thanks for coming along to my talk this afternoon. This is the bonus talk that I'm giving to fill into a slot that sadly got missed out. So hopefully this all goes well for you this afternoon. My name's Phil Nash. I'm a developer evangelist for a company called Twilio. Can I just start by asking, has anybody heard of Twilio here at all? Pop your hands up. All right, a few, that's cool. There's a few hands down, of course, so let me just explain. Twilio is a communications platform for your applications to connect or communicate with your users via voice, video, or messaging using the tools, languages, and frameworks that you already know. I'm not here to talk about Twilio, of course. I'm here to talk about browsers doing work behind your back. Although I will warn you that Twilio does come up as part of my example. You'll see why in a minute. So what do I mean by this? Well, first, I'd like to say that email's pretty cool. I don't mean that you can just have people send you stuff and that get a little counter that rolls up on your phone and you get embarrassed because you haven't answered any of them yet. I know I have 130 unread emails at the moment. That's cool. And I didn't have a PagerDuty or anything. But this is kind of what I mean. That when you type out an email in a native application and you send it, and then maybe you close the application, or maybe you didn't have a very good signal when you sent that message, whatever happens, you can be pretty certain that at some point that email is going to send. Well, we know that because it's gone into an outbox, and we've heard of email outboxes before, and we know that it's kind of storing it and waiting to send it off. And if it does ultimately fail because it tries and tries and tries, it'll tell you about it and notify you that. But on the web, do we have that as JavaScript and web developers? Well, we've been working on these things called progressive web apps, and I hope you've heard of this term before, and I'm sure you'll hear more about it later in the conference from Ada. These progressive web apps, the idea is that we can kill this guy. So we never have to see this dinosaur again. We never have to play the game again. We never have to watch him trip over cactuses over and over again, just because we dropped out of signal. We had a bad connection. But what happens when, we've done this via caching APIs and the service worker, which has allowed us to store parts of the site offline and then access them. But what if we're doing something like sending messages, or liking or favoriting something, or adding shopping to a cart, for example, or even leaving a comment, all sorts of actions that require posting a form to a server? Caching an HTML response is not going to save us here, and so we remain stuck with the dinosaur, or at least some sort of page that says, "I'm sorry, you're offline, try again later," which is a terrible experience. And so if we want to make these progressive web apps work better, then we have to do more about that. And that's why I want to talk to you today about the background sync API. The background sync API is made up of three parts, really. There is the service worker that I've already mentioned as part of a progressive web app. I think we need to know a bit more about IndexedDB, and you're going to hear quite a bit about that from me over the next 2 days. And then there is the sync event, and I will show you how that works all together. So let's start with a demo. I want to show you what I'm going to be working with today so that we know what our end result hopefully is. And so over here I have Chrome, and on the right-hand side is my phone. And so this is a very simple application that simply sends text messages to myself. Very boring, like I said, uses the Twilio API, and there it goes, there's a little test messages in the background. And the message comes through, hello. That's all we've got right there so far. But if I was to turn the network off, that would fail rather miserably, because there is nothing, you would just get that offline page when I enter the form. So that's what we're going to fix. We're going to make that form work regardless of the network conditions, regardless of the ability of us to reach the internet. So let's start with the service worker. Has anybody worked with the service worker at all before? All right, we got a few. That's cool. That's cool. If you haven't worked with it, then it's a wonderful thing because right now we have, before the service worker, this was our model. We would go from browsers to servers. Servers are now clouds, of course. And that's all that would happen. And if there was a break in that, then, dinosaur. Instead, the service worker is a piece of JavaScript that you can install to run in the background, entirely out of the context of the page that installed it. It can run when the page isn't even live in the browser. And this allows us to make requests, and it intercepts those requests, and then it can do whatever it wants with it. It can just make up a response using the response object, which is part of the fetch API. But it can also it can go get that response from the cloud as well. It can store it in a cache, and it can always return that cached file. But this is what we've got. We've got this bit of JavaScript that is able to intercept network requests and run in the background, and now it can do a lot more. If you've seen push notifications as part of web applications these days, that is also powered by the service worker, and its ability to be woken up by a push event coming in and then notify the user that something happened. And that's what we're going to see with the sync event as well today. So that's the service worker. Then there's IndexedDB. Who's worked with IndexedDB at all? All right, a couple more people than service worker. Put your hands up if you enjoyed working with IndexedDB. One out of all those. Okay, cool. We're using a really nice library. Like, no, just the what? Sorry, just the browser API. Okay, and you liked it. All right, cool. Nobody else does. And that's fine. That's fine. IndexedDB is a bit weird, right? It is that browser. It's that server. It's a database that we have inside the browser. I think it's a good thing. One person agrees with me, and we'll see more about it tomorrow. But just for a brief introduction to it, if you haven't worked with it, it's an object store, not a relational database. It's an object store. It's asynchronous, which is good because service workers do not like things that are synchronous. It's transactional. This is part of the asynchronicity in that you have to create and run all your commands to the database within a transaction. And then the browser itself would queue up those transactions and perform them, which is, and then you get the result, which is why it comes out as asynchronous. And finally, it's quite a low-level API, which is why I'm surprised you were just using the browser, the API itself. It's decided it was low level. In fact, I read somewhere that it's in fact the design of the IndexedDB API was based very heavily on the XML HTTP request API, presumably an API that no one's used in the last 15 years because we've had so many libraries to deal with that instead. XML HTTP request was horrible, but it allowed us to do something, and hopefully that's the case with IndexedDB as well. So it's low level, so I probably suggest using a library. Just so that you have less pain, less hassle with it. And I've just got a couple of options here for you. IDB is kind of the one I'm going to show a bit of, or you're going to see a little bit of, during this particular talk, because IDB returns promises. It wraps the whole IndexedDB up in a promise kind of API as opposed to a weird callback set of callbacks API. Local forage is a replacement for local storage API that runs asynchronously, built by Mozilla. Dexy is a pretty cool, fully featured JavaScript, database library. Also returns promises and is kind of nice. And finally, PouchDB. PouchDB is really cool because it implements the entire of CouchDB in the browser on top of IndexedDB, including this. This includes the CouchDB sync protocol, and so that IndexedDB within the browser using PouchDB can actually just become one node in a distributed set of CouchDB instances, which I think is an absolutely amazing thing for a browser library. Have a look at those, pick the one that you need. It's quite cool. As I said, we'll use IDB. And we'll use IDB because service workers do, in fact, love promises. You can't get away from promises within the service worker. And so callbacks, and this is that normal IndexedDB API where you have to open a database and then wait for the onUpgrade needed event, and the onSuccess event, and also an onError event that I couldn't fit on the slide. And it's kind of like, it's a bit nasty, it's a bit horrible. And yeah, service workers will not enjoy that either. This is IDB. It's a very thin wrapper, but all it does is, promisify those kind of things. And so the upgrade stuff is done simply within a normal callback. And then when the promise resolves, you have your database. And that's kind of cool. If you want to know more about IndexedDB, about why I think it's important, then join me tomorrow in this room at 3 o'clock with the talk, An Empty Database in Everybody's Pocket. It's kind of given the answer to what the empty database is, but IndexedDB. We'll talk more about it later. But let's see what I want to do with IndexedDB for this particular demo. This is the code for the demo. The current front-end JavaScript. It registers a service worker. It gets hold of a form for me. I have this method here which pulls values out of that form, but that's just to use so I don't spend the entire time talking. And we're going to do some stuff with this now. So when my service worker is successfully registered, I actually want to listen to the form to stop it submitting stuff, because if we've got the service worker, then we're going to use our sync API, and so I want to stop this submission. So let's stop that. Cool. And then we want to put the things that are in our form fields, the number and the message that we want to send, we want to store those into IndexedDB. Nice and easy. So I have a little wrap around IDB called store, which allows me to get hold of an outbox, and in this case I want it in read-write mode. There are two modes for IndexedDB, read-only and read-write, but we're putting things in, so we need to write. Again, as I said, this is all promise-based, so that's kind of nice. When we get that to resolve, we get an outbox object. And so we want to store, we want to put our message, and this is going to get the message from the form. Oops. We want to store that message inside the database. That's kind of all we need to do, right? We're going to open the database up, and when the form submits, put a message inside it. And so if I were to go back right now and refresh this page, that should have loaded up the JavaScript. And if I write hello from IndexedDB and press send, we should see this not go anywhere because we've intercepted the form request. Cool, it didn't. And that means that if we were to refresh IndexedDB and look inside that instead, we have our outbox, and we have, let's just move that over, we have our objects in here, and that is the message we were trying to send, hello from IndexedDB. Cool, so we've got in the way of the form, and now we're not sending any messages at all. Super useful. Let's go back to the slides. This brings us to the background sync API. This brings us to the apparent hot corner that I found about earlier. This brings us to the background sync API. The background sync API, I think, has a weird name because it relies on this sync event. And the sync event doesn't fire all the time. It doesn't fire when you want it to fire. What it does is just collect up and wait. For this particular instance, the zero network or flaky network or terrible network or Li-Fi, if you've ever heard that term. And when it comes back, when you get a connection again, the background sync fires. The sync event will fire. So to me, it's kind of more of a back online API. Background sync sounds weird. If you are online and you register for a sync event, it fires pretty much immediately because you're already back online. I should probably tell you about the browser support. One, because we need to know whether we can use this or not. Before I do go through that, remember this is a progressive enhancement. This is something we can add to a site, and if we don't have access to it, then submitting a form will just work as a normal website does. And we get an offline page, maybe if you're offline. But this does not change how that works for users that are using browsers that don't support it yet. So the good news, it's available in Chrome and has been since version 49, which is probably about 10 years now. And they've got loads of versions. I don't know where we are. It's in Chrome 49. It's also it's been available and they've added it into, if you don't know this browser logo, that's the Samsung Internet browser. Apparently the third most used browser on mobile these days, as it is installed on all new Samsung devices. So it's in their beta. Apparently it was broken in that beta, but they were fixing it. So it's in the beta. It's a good sign. It's been developed by Firefox. There is a long thread on Bugzilla going through all the blockers and the things that need to be done in order to get the background sync API to work in Firefox. But what that shows is progress. It's working. It's getting there. Similarly, the Edge team are working on it, and they have that on their site. Their status.modern.ie, I think, says that Edge team are working on this. I'm fairly confident that the next large version release of Edge browser will finally include service workers, and I can start moving that logo further towards this end of the screen. Hope so. It's also apparently being developed in Opera. This is a weird one because I can only find out this information from, again, the Edge team's status page, which said that Opera were working on it. I couldn't find a status on the Opera site. Who knows? And then iOS Safari, or Safari in general. Any guesses? Yeah, I mean, that's all we have is guesses, because Apple loves to be secret about these things, right? It's rather a shame, but hopefully, I believe they are working on service workers. I believe they have this in the future as well. But right now, we just don't know. It's not too long till WWDC. Maybe they'll talk about it. I don't know. Let's hope so. So this is how it works. What you need to do to register for a sync event is when something happens and you have a service worker registration. If you've not seen this before, navigator.serviceworker.ready is just kind of a pointer to the promise that gets returned when you initially register a service worker. And so this will always return eventually the registration of a service worker. And then use the sync object on that to register for a tagged event. So this little string can just be looked up on the event later. That's all you have to do. I mean, if you can check for the existence of this sync object, so we don't try and do this in a browser that doesn't support it. But apart from that, we just register for an event. And then in the service worker itself, you listen out for that sync event. And as I said, you can check for that tag, and you can do different stuff if you have different events, different things happening in the front end. That's kind of it. It depends on what you want to do with it. So let's see. Let's make this happen. Let's use the sync event to store our messages, and then when they get synced later, we will send them off. So first up, I need to finish off the front end. So once we've put our message in IndexedDB, we want to register that sync event. Return. We've got the reg. I already have that from up here, and it's sync. Oops, let's put that up there. Register. I'm just going to call it the outbox event. It doesn't really matter because I'm only doing one event in this particular application right now. So I'm not going to check for the tag, but I'm going to tag it outbox for now anyway. And then this is the service worker file. I have a couple of scripts imported at the top, as you can see. This is IDB just for using IndexedDB, and this is my little wrapper store. And these are some request headers that I'm going to send with the send with the request. So let's get rid of those out of the way for a sec and get into listening for the sync event. That's cool. We're actually going to tell the event to wait until we're done. The service worker can be killed kind of by the browser at any time. So if you're doing something important, like reading some messages out of a database and sending them to the server, it's probably best to tell it to wait for that to happen. This takes a promise, so we'll start with the promise we were using earlier. And I'm going to open up the outbox in read-only mode this time. That will get me an outbox. From that outbox, I'm going to return all of the messages that have been stored. That's cool. So that resolves that promise with a list of messages. And then I need to map over those messages, send each of them to the server. When we get a response from that, we're going to delete the message from the database so we don't end up sending multiple messages. And that's kind of it. Of course, I need to respond as a promise. So we're going to go promise to all over these, and then messages.map. Oops. Messages.map. And that function will get a message each time it runs through. So we're going to return fetch to messages, which is the endpoint that we needed to call, and send in some options. The options are, we are going to post this. We are going to use the body, which is the message itself. This time we have to stringify the JSON, the message. And finally, we're going to set those headers. And they're just listed at the top in the request headers variable. Cool. So after we fetch, we're then going to delete the object from the database. That makes sense, hopefully. In this particular case, we actually have to get the outbox again, but in read-write mode because we're deleting stuff. So when that function goes, we'll have the outbox, and we can just call outbox.delete message.id, and that ID is generated by the browser itself. So that's all the I think that's all the code we need to write. You see, we're going to go through our messages, send them to this server, remove them, open the store up, remove them from the store. Let's go back to this, and we get that up, refresh that, and here it comes, slowly. Cool, who's using the internet? Should be, oh, no, me, I'm using the wrong one. Ha. That's cool, that's failed nicely. We have the latest service worker installed there. It's got all the stuff we just wrote. That's a good news. So what I'm actually going to do is turn the Wi-Fi off. I don't need this for this point because we're going to make this work, right? This is the bit where the Wi-Fi is off and I have no connection. Hello from offline. And so what we should see at this point, let's go back to that application. I'm going to hit send again. Now I haven't cleaned up the UI, we can see that. But if we go and look in the outbox, refresh that. Refresh the outbox. Nah, okay, this never works for me. That's DevTools. Before I check to see whether this actually works, I want to tell you about a couple of other things quickly. I want to tell you about the future. First of all, there's the background fetch API. This is very new. It's very new in Chrome Canary and right for testing right now. Background fetch API is for fetching large files, big downloads, or making large uploads as well. Very useful if you're a photo site, podcasts, movies, all sorts of things like that. And it allows the browser and the service worker, your site, your JavaScript, and the service worker to control the uploads and downloads of these files. It works in a very similar way. So in this case, if we have a URL, which is a large file.mp3 in this case, we just call on the background fetch object of the service worker registration, and we call fetch on it. Downloads there is a tag, and this is a list of URLs, in this case 1. And then you can set some other things like some icons, a title, and this is kind of for the browser Chrome itself, that download Chrome that you see in browsers, to use and show the user what's going on. You can set a download size, that's a hint to the browser just to start with their progress bar. And then in the service worker, you listen for, and this is the success, background fetched. We've done it. We've fetched all the things. We can put them in a cache. We are ready for our user to open the page again at some point. And so you can also update the UI at this point, so you can say that it's downloaded, and that will appear in the browser. And I think this is pretty cool. Like I said, it's really good for large file uploads and downloads. There are some other things, so you can get notified if actually the fetch fails or is aborted. And if somebody were to click on the browser Chrome, you get the background fetch click, which means you can open your site up in the, under the file that you expect to see. So if it is a podcast or indeed an array of podcasts, you can you open it up on that page and show that within your own site. I think that's pretty cool. It's available for testing, as I said, right now in Canary, Chrome Canary. Then there's the periodic sync API. This is the one that is going behind your back the whole time and doing stuff. Except it's not yet, because it's not in any browsers. But they're working on it. I think it's interesting to see these things come as the future. As the periodic sync API, again, works very, very similar. And we have a periodic sync object, which you can register for. This is much like the actual sync object. But in this case, we can tag it, but we set a minimum period. And this is the least amount of time that's going to elapse. Least amount of time that's going to elapse between one run of the thing and another one. This is not an alarm kind of API. That's not an exact amount. It will happen sometime after the minimum period between syncs. This, I think, is particularly useful for loading things in the background ready for users to read. My example that always comes to my head is like a news application would go and get the latest articles for the next day, probably every morning. They would try and get every morning so that when the user wakes up, checks their device, they don't have to download the things at that point. The news and the latest articles are there ready for them that day. You've got these kind of interesting options here as well. Power state avoid draining and network state avoid cellular. And this is just being nice to people on mobile devices. I think that's really, it's good that they're thinking about this thing as part of the spec. This is what happens on the other side. You get a periodic sync event, very much the same as our background sync. And talking of which, let's see if that background sync did in fact work. I'm going to bring back our app. I'm going to bring back my phone, and I'm going to bring back the Wi-Fi. And what should happen is, as the Wi-Fi reconnects, and let's hope it does, because I've run out of time otherwise. If the Wi-Fi reconnects, the browser will send that sync event to the service worker, Do you know what? It's actually quite exciting. I'm gonna close that. As the Wi-Fi reconnects, it sends it to the the browser. The service worker receives that update and then goes and fetches the things out of IndexedDB, sends them to the server, which is going to send them onto the Twilio API in this case and send the text message through to me. And there it is. Hello from IndexedDB. And hello from offline. If you want to go into more depth on that, there's a blog post right there. The slides and everything will be online as soon as I can afterwards. Thank you very much. I'm really glad that worked for you. There's some credits there. And the link, please go and rate this. Use the QR code, because QR codes are cool. And otherwise, I think we are way out of time. So the link is on the next slide too. Thank you very much.